Okay, this is a review for Chapter 10. There's the first answer. The second answer is log base 4 x squared, and the division becomes a minus log base 4y. This you can actually keep going because you have an exponent right here. So you could write the exponent out in front, 2 log 4x minus log base 4y. The next one, we're condensing logarithms. So we're going to go from 2 logarithms to 1 logarithm. So this one would be log base 3 and a product xy. This would be log base 4, 2 times z times w. And you can write that as 2wz in alphabetical order. This one, you have a difference, so you're going to have log base 2 of a quotient, 2b over b. And the b's divide out, so you have log base 2 of 2. And log base 2 of 2 we can actually simplify to be 1. Why is that? Well, this right here is the same as 2 to the what equals 2. That's another way to write log base 2 of 2. So the answer would be 1. This one we could write as log base 3 of p cubed. And that's all we could do with that. The next two, you can do 2 steps at once. You have to move these coefficients first to be exponents. So it would be log base 3 of q squared times p cubed. And that would be condensed. You usually use these properties to solve equations. So it's good to know these properties. And then this one you'd have log base 5 of x to the 4th minus log base 5 of 2 to the 5th. And the difference you can condense to be a quotient. So this difference is going to become a divide. So you have log base 5 x to the 4th divided by 2 to the 5th. 2 to the 5th is 32. On a question like this, between 2 and 32, it's better if you don't use logarithms, and instead you use what's called common bases. So if I ask you on your test to use common bases, I mean to do this. You look at 2, you look at 32, you pick the bigger one, 32, and you're going to make it a smaller base. So 32, you want to make a base of 2. So this 2 is going to stay the same, 2 to the 4x plus 1. But 32 we can write with a base of 2. So it would be 2 raised to the 5x. 2 to the 5th is the same as 32, so we're just substituting what 32 equals. So now the bases are the same, you can ignore them. You have 4x plus 1 equals 5x. Subtract 4x from both sides, you get x equals 1. On the next one, you can solve for x. You have to isolate the base e first. So when you isolate, you divide both sides by 4. You'd have e to the negative 2x plus 1 equals 3. At this point, you have to get rid of the e. To get rid of an e, you have to do the inverse operation, the opposite operation, which is ln, natural logarithm. So when you ln both sides, the ln and e cancel. You're left with negative 2x plus 1 equals ln 3. And then you'd subtract 1, divide by negative 2. So you have x equals ln 3, subtract 1, and divide the whole thing by negative 2. And you would get this for an answer from your calculator. So that's the answer. On the next one, you need to rewrite these. Your base is 5, so you have 5. Logarithms equal exponents, so that's 2 equals n. So the answer is 25 here. On this one, you'd have n cubed equals 27, so n is 3. And the next two, you have to use logarithm properties. You have to condense here, because you have 2 logs. This 2 needs to move to be an exponent. So you'd have log base 4 x times 10 squared equals log base 4 of 30. So they both have log 4, so you can ignore them. You have 100x equals 30. So x equals 3/10, or 0.3. The next one we have to condense. So condensing these would be log 2, x plus 2 divided by x minus 2 equals 3. So we would have x plus 2 over x minus 2 equals, this log 2 comes over here and makes it a base of 2, because that's what our base was, base of 2. So it's a base here with an exponent of 3. So 2 cubed is 8. So you'd have x plus 2 equals 8 times x minus 2, which is x plus 2 equals 8x minus 16. So you would subtract, so that would be, add that, so 18 over 7 would be the answer for that. On the next one, use a calculator. You'd have to use change of base formula. Change of base formula says for one like this, anytime you have a log with a base that isn't a base 10, you would write log 19 divided by log 3. And you would get the answer with your calculator. It's, I think, 2.6 something. 801. Thank you. The next two questions, when you have a variable exponent, you would log both sides, bring down the exponent, log 4 equals log 25.2. And to solve for x, you would divide both sides by log 4, and then subtract 2. 3277. The next one I have to change, so we're able to solve it without the quadratic formula. We'll make this a ln2. So to solve this, we condense the two ln's. Log properties still hold. We have ln, and the plus is going to become a multiply. So it's x times x, and x times 1 equals ln2. And they both have an ln, so we can cancel the ln's. We have x squared plus x equals 2. Subtract 2 from both sides. And then we factor to find the answer. So this would be x plus 2, x minus 1. So you get two answers, x equals negative 2, x equals positive 1. But negative 2 is extraneous. This one is extraneous because when you plug it into this x right here, you would get undefined for the answer. For the next one, a natural logarithm. Natural logarithm has a base of e, and a common logarithm has a base of 10. So you should know the difference. Common logarithm, it's very common to count base 10. We have 10 fingers. It's very common to have 10s, 10 toes. Natural logarithm is e. Okay, word problem. For this word problem, I'll give you the formula, which is y equals a 1 plus r to the t. Your initial, the a value, initially it's 250,000 people, so that would be 250,000 people. Your interest or your rate of growth for people is this percent as a decimal. And it's, notice the years, from 1930 to 2011 is how many years? 81 years. And then you can just type this into your calculator. There's no solving that you need to do. So when you type it in your calculator, I forget the exact answer, but you get something like 8.8 million people in this town. So it's been growing quite a bit over 80 years. That's an approximate answer. For the next question, yeah. On the next question, borrowing money and its monthly compounding. So you'd use the long formula. So this would be the formula. And you do need to memorize this formula. you have $100,000, that's the principal, 1 plus. The interest rate is 0.095. And since it says monthly, your N would be 12. And this is 12 up here, after 10 years. So that's one where you're actually told straight out that you have after 10 years. And you're solving for your amount, so that one's pretty nice. You can crunch the numbers. I forget what the answer is. It's something like $250,000, something like that, or 260. Approximate-ish. Not sure. It's somewhere around $250,000. I want to look at this question right here that was added in to the notes. So this is a continuous compounding one, which I didn't put on that, but I put up here. So if it's continuous compounding, you use A equals P e to the RT. Your grandparents give you $150,000. It's very nice of them. E is a constant. Your interest rate is 0.025. And you want to know when you're a millionaire. When will you be a millionaire? So that's the A amount. When will you have $1 million? $1 million. And you're solving for T. So to solve for T, you would divide both sides by 150, so that's going to drop out 4 zeros. That would be 15. E to the that. And then you have to solve for T. So to get rid of a base of E, you had ln both sides. So you'd have ln of whatever this number is equals 0.025t. So t equals ln of 100 divided by 15 divided by 0.025. And I don't know that answer. ln 100 divided by 15 divided by 0.025. It would take 76 years for you to have $1 million at that interest rate. 76 years. 76 years. So it's going to take a long time, but if you start now and you have $150,000, you'll be able to be a millionaire by the time you're in your 90s. So congratulations. Thanks for watching this video.